we have already seen that the derivative of sine inverse of x is 1 over the square root of 1 minus x squared, and therefore the antiderivative of 1 over the square root of 1 minus x squared will be sine inverse of x. But now we like to extend this integral. Instead of 1, if we have a squared. And so we like to show that the antiderivative of the integral of 1 divided by the square root of a squared minus x squared is equal to the inverse of the sine inverse of x over a. And so first, let's simplify this right here. And so this is the same as if we factor out the a squared. And so to factor out the a squared, just put the a squared in front of the parentheses and then divide everything by a squared. So a squared divided by a squared is 1, and then minus x squared dividing by a squared. And so this integral becomes this. And then the square root of a squared is just a. dx. And then now we'll use the substitution method to find this indefinite integral. And so let u squared be the x1 minus a squared. And then take the square root of both sides, so we get u to be x over a, which is the same as 1 over a times x. And so we have du dx will be 1 over a. And so this means that du is equal to 1 over a times dx. And then now multiply both sides by a, and we get a times du is equal to a times 1 over a dx, which is dx. So this integral now becomes this. This would be u squared. And then du is just a times dx. Dx is just a times du. And then the a here will cancel out. And so up here we have the integral of 1 dividing by 1, the square root of 1 minus x squared is sine inverse of x. And therefore the integral of 1 dividing by the square root of 1 minus u squared, this will be sine inverse of u. And then this becomes sine inverse, but u is x over a. And then plus c. And so we have just proved this right here. And so instead of 1, if we have an a squared right here, then it becomes x over a. So if we just have the integral of 1 divided by the square root of 1 minus x squared, then it'd be just sine inverse of x. But if we change the 1 to the a squared, then this becomes sine inverse of x over a. And which leads us to the following formulas. And so the antiderivative of an expression like 1 divided by the square root of a squared minus u squared. So we have just seen a squared plus x squared. But if we're using the letter u, then it'd be just u. Then it'd be sine inverse of u over a. And similarly, we can also show that the integral of 1 over a squared plus u squared be 1 over a tangent inverse of u over a. And we get this integral right here is from this formula. And then we have seen that the derivative of secant inverse is 1 over absolute value of u, and times dividing by 1 dividing by absolute value of u times the square root of u squared minus 1. And from here we get this formula, the integral of 1 over u times the square root of u squared minus a squared is 1 over a times secant inverse of u divided by a. And so what it means is this: anytime we have an integral where we have the expression 1 dividing by the square root of a squared minus u squared, then we would use this formula. If we have an integral with the expression 1 dividing by a squared plus u squared, then we would use this formula. And then we have something like 1 divided by u and then times the square root of u squared minus a squared. And so now, so here from the sine inverse, tangent inverse, secant inverse, we got expressions like integral of expression like square root of a squared minus u squared. What if we turn this around? What about u squared minus a squared? If we turn it around, then we need the inverse hyperbolic functions. So earlier we have seen that the derivative of the hyperbolic sine is 1 over the square root of u squared plus 1. And then instead of 1, if we have an a squared right here, then we can just do a proof similar to what we just did. And then this will come out to be the natural log of u plus the square root of u squared plus or minus a squared. And so this formula is coming from this. The plus is the plus right here, and then the minus will come from the derivative of the hyperbolic cosine. And so that's where the plus and the minus comes from. And then we have also seen that the derivative of the secant inverse is this, and then from this formula we get this integral right here. And then the derivative of the cosecant inverse, we get negative 1 dividing by u plus 1 plus the square root of 1 plus u squared. And we get this formula right here. And so the only difference is minus here and then plus here. And so minus, plus, minus, plus. That's the only difference. And then the last formula, we have seen that the derivative of tangent inverse is 1 over 1 minus u squared. And then we get this formula right here. And then from here we could also extend it. If we multiply both sides by negative 1. So multiply the left side here by negative 1. Multiply here the right side here by negative 1. Then negative 1 times the a squared minus u squared, that just turns it around. That would be u squared minus a squared. Then we get negative 1 divided by 2a times the natural log of this. And again, so what it means is this. Anytime we have an integral that has the expression square root 1 dividing by the square root of u squared plus or minus a squared, and then we would use this formula. If we have something like 1 dividing by u times the square root of a squared minus u squared, then we would use this formula. The difference is this. Earlier from the from this formula right here. Here is u times the square root of u squared minus a squared. But here is u times the square root of a squared minus u squared. So that's the difference. And so we have to look at our integrand or our integral and then decide which formula is appropriate. And so now we'll do several examples using these formulas.